This is Mr. Grindy once again with section 2.1.2. Before we get started, we want to make sure that we have our ebook open to 2.1.2. We've got our toolkit for chapter 2 open and ready to go, and we have our notebook and pencil ready for taking notes. Pause here if you need to. The objective for today is that we're going to be able to determine that when a transversal intersects parallel lines, corresponding angles have equal measures. And the math practice addressed today is that we're looking for patterns and structure in angle relationships. Also, today's lesson will be filled with information about Carl Friedrich Gauss, a German mathematician born in 1777. If you're ready to proceed, go ahead and open your ebook to 2.1.2, problem 2-14, and we'll get started. Now that you have your ebook open to the right section and you have your resources ready to go, read through question 2-14 down through A, and then we'll discuss that in just a second. Pause the video here. Now that you had a chance to read through it, let's start with the opener here, talking about this term tiling. So when they say tiling, what they mean is this graphic here, where we see the same shape reoccurring over and over and over. In this case, a parallelogram is tiled over and over and over. Now, if you don't have a printer to print out that resource page, this e-tool is really handy, and it starts out with a template, like a guide, and I'm going to slide that to the right, and you can see underneath it is a parallelogram that it lays over nicely. And when I slide up and up or right or to the left or down, I get more of these parallelograms. And question A asks you to color in all of the angles that are the same. Now, if you don't have a printer at home, you're not really going to be able to color these in, but I can show you what it would be asking you to do. And basically it's just asking you to identify all of these are the same. So for instance, let's use something a little bit bigger there. For instance, this angle here would match nicely with this angle here, would match nicely with this angle here. Actually, let's switch to this again. All right, I'm going to leave the rest not filled in. And then there's some other angles that are exactly the same. So you might be thinking that this angle here is the same as this angle and this angle. Because of the tiling, it's just occurring over and over and over. Then we also have these angles down here. We have these angles down here. This angle congruent to this angle is the same as this angle is this angle. I use that word congruent sometimes. We haven't really talked about it yet, but we will get to what that means. And then lastly, this angle, this angle, this angle, this angle. All of these repeating are all the same. Okay? And that is what question A is getting at. So now take a second and read question B. Pause the video here. So now that you've had a chance to think about question B, what it's really asking is which angles around this parallelogram are going to be the same. And you might notice it right off the bat, you might not, but if you think back about that graphic that we just saw, we went around and we colored a lot of these angles the same color that were in the same exact location. Right? But if we were to continue this, one thing that you might notice is this red angle up here is also here and is also here. But then notice that the green angle and this red angle, so this red angle here and this green angle here, now have a very special relationship that we've seen already, and those are vertical angles. And we already know that vertical angles are always the exact same measure, telling me that the green and the red angles must be the same value. And then the same thing happens here with our yellow and our black angle, meaning those two angles are also the same. So that got a little bit messy, so I'm going to erase that and get to the gist of what question B is saying, which is essentially that on any parallelogram, this angle and this angle are the same. This angle and this angle are the same. And then go ahead and read through question C, pause the video, and then we'll discuss it. And for this question, it's just asking us to get comfortable with the idea of marking lines parallel. You probably noticed that the top and bottom lines are parallel, so I'm going to put an arrow just like this to signify that those two are parallel. And then I'm going to do the same thing on the sides. But it would be confusing for me to just leave one arrow on the sides. I'm going to give it two, because what that does is tells the reader that the two arrows are parallel to the two arrows, and the single arrows are parallel to the single arrows. And you might be asking yourself, could I use more than two? Yeah, you could use 3, 4, 5. It's really up to you, as long as you use the same number of arrows for all of the lines that are parallel. Interesting fact about Carl Gauss, even though he's one of the most famous mathematicians of all time, he was actually born into a really poor family. So poor that his parents weren't even able to write down the date in which he was born, because his parents weren't educated, and he wound up being one of the most influential and important mathematicians of all time. And now we'll move on to question 2-15. I want to talk about this toolkit. On the last lesson video that you saw, we didn't pull out the toolkit, and there's some things we should have filled in. So let's start with the complementary. Remember, complementary means two angles that sum to 90 degrees. Now, your toolkit might not look exactly like this, but it should look similar. Supplementary means two angles that sum to 180 degrees. And if you're not familiar with toolkits, your teacher has not given you one, you can ask them, or this could just be something that you add into your notes also. And then down here I want to add in congruent, because we've talked about congruent several times already and we haven't defined it for my class yet. So remember, congruent is congruent is two shapes, and we're going to make this a simple definition: two shapes that are the exact same size and shape. That's it. Two shapes that are the exact same size and shape. And then we've got two terms here that we learned about at the end of the lesson last time. The vertical angles. Remember, vertical angles are equal measures. And remember, a linear pair are two angles that form a straight line and sum to 180 degrees. And I'm going to add to vertical angles. Vertical angles are equal measures, but I'm going to also add in there that they are opposite each other when two lines intersect. And then